Wonderful. Good morning. My name is Joy DeBolt. I work here at SAS, and we're thrilled to have you here at SAS Innovate this year. This morning, I have the pleasure of introducing our speaker, Sean Peasy. He is going to take it away and show you the updated SAS DataMaker. Let's give him a warm welcome.
Thank you. Hey, good morning. My name is Sean Peasy, and I'm here to talk to you about the all-new updated SAS DataMaker. In this talk, I'll give a brief introduction about myself. We'll have a little history lesson about the origins and the current state of DataMaker, which is SAS's synthetic data generation solution. Then we'll talk about the new features that we are debuting here at SAS Innovate for the next version of DataMaker. We'll talk about how you can deploy SAS DataMaker, a little bit about the architecture, and then we'll do a live demo diving into those features that I talked about. Afterwards, we'll talk quickly about some of the new features that we're working on post GA, and hopefully we have some time for questions at the end. Oops. So as I said, my name is Sean Peasy. I'm a senior manager at SAS. I've got 25 years of experience as a software developer, the last 3 in management, and I've been at SAS for the last 13 years. And over those 13 years, I've gotten to work on many products. SAS Financial Management was a solution, and most recently on Visual Machine Learning, which is part of Model Studio in SAS Viya. I also have the privilege of leading the DataMaker team here at SAS, and I lead a very different team at SAS. I get to work on a lot of different things. So I've got people working on Workbench, if you know what Workbench is, SAS Viya Copilot for Model Studio, we contribute to that. So I get to work on a lot of different things at SAS, and so I get to see a lot of the new features that we're putting in. So let's talk a little bit about the history of DataMaker. A year ago at Innovate in Vegas, I gave a very similar super demo where we launched an initial private preview of DataMaker. And if you saw that, it was a very simple solution. It was fully software as a service. You would upload your data file, we would process it, generate the data, and it would automatically download. Very little control over how the generation process worked. We only supported a single algorithm, which was SMOTE at the time. And really we wanted to do that to get in front of customers and get feedback on what your use cases are and how we would build out a solution that would meet your needs. So last summer we took that feedback and we started building out DataMaker with the feedback that we got. And then in the fall, we had an opportunity to acquire Hazy Software, and Hazy was a synthetic data generation startup. They've been around since about 2017, 2018. So they've been doing this for a long time. They come with a lot of experience, a lot of great features that checked a lot of the boxes that our customers asked for when we got that feedback in that initial private preview. So last fall, in addition to the software, we onboarded a fantastic team of engineers that I get the privilege of working with every day. And over the last 6 months, they've been hard at work, not only onboarding and learning what it is to be a SAS employee, but taking all those cool features from their Hazy software and bringing it into DataMaker to make it the product you're going to see today. So today I'm here, it's May of 2025, just about a year after our last one, and we're going to start our next private preview in a couple of weeks with this updated version of DataMaker. So what were some of the things customers asked for? The number one bit of feedback I got at Innovate last year is my data is not in a single table. We've got multiple tables, there's relationships. I need to be able to generate that relationship. I don't want to have to put everything in a single table, generate, and then break it out. So the Hazy acquisition brought us multi-table generation out of the box. In addition, a robust set of semantic types. And so typically at SAS, You define a column and it's a character or numeric, and you can define some things like roles and levels. But Hazy brings a lot of semantic types like name. Name is something very specific, and it informs how you train your model and how you want to generate. Location data such as zip codes, genders. Incorporating these semantic types allows us to really control and tailor how we build a model and how we generate data so that you get high quality data out of the back end. We get a whole collection of new generation methods. As I said, last year we only supported SMOTE. This year we've added 2 additional methods. One is a Bayesian network called PrivBayes that Hazy brought. And in addition to that method, differential privacy. This is something that's very important to the customers that we talk to, especially in industries like healthcare and finance, where you need to be able to generate synthetic data, but you don't want to leak the private information that's in your actual data. Maybe you want to share that data with your modeler so they can build workflows or train models. But the addition of differential privacy, which is a mathematical guarantee that you cannot reverse engineer your synthetic data to anything from your source data. And it does that by injecting noise at various levels through the training process. I said there were 2. The second is time series generation. This was another feature that people asked for that we did not have in DataMaker. We actually did not have at SAS at the time, so this acquisition brought multiple time series generations, and we're incorporating one in the GA launch of DataMaker. So now I'm going to quickly talk about how you would get DataMaker. We're targeting right now as a standalone application. So that means you don't need to have VIA or for full VIA installation to use DataMaker. We're going to target Azure for GA, and it will be a managed application from the Azure Marketplace. We are taking a page from SAS VIA Workbench, and we are utilizing their split plane architecture. And what this means is the application itself will be deployed in you, the customer's Azure tenant, but we will host a small control plane in our tenant, and that allows us to manage the infrastructure and the application. So as we push security fixes or new features, your application will automatically pick those up because we can push them out. So it's kind of a hybrid software as a service solution, but it allows the application to run fully in your tenant, which means you maintain data sovereignty. Your data doesn't need to move to SAS. No data from your environment ever comes to SAS. Very simple picture of what this looks like. We've got that control plane hosted by SAS. That data plane is hosted in your tenant. The DataMaker application runs in there, and we have this auto-scaling compute pool, so that means that we're not using cloud resources when DataMaker is not being used. So as it gets used, people start training models, generating data, analyzing data. We'll spin up those compute nodes for the life of that work, and then when it's done, it will spin them down to help reduce your cloud costs for running DataMaker. There is that link. It's a virtual private link from the data plane to the control plane, outbound only. The control plane never talks into your data plane, and the only thing that's really asking for is there anything I should do? It does that periodically. It might get something, no, there's nothing you do, or hey, there's an update to the software, go pull those new containers, restart the application, you pick up the new features, security fixes, automatically seamless to you. This allows you to focus on getting value from SAS DataMaker rather than having to worry about managing the infrastructure and the application itself. So we're trying to simplify all of this for the customer. So with that, I'm going to switch to a demo. And so this is SAS DataMaker, and it looks a lot like typical SAS applications that you would see. We are using the same themes because we want that common look and feel across all of our applications. And I'm going to create a new project. And you give it a name. And I'm going to create this project to kind of show off the set of semantic types and the concept of entities. and then I'm going to switch to a different data set to do the full end-to-end demo. So I'm going to create that project, and the first thing you have to do is add data. And I'm going to select a set of movie data that we have. This is movie ratings for customers. And the first thing it does is it starts this analysis process. And what this analysis process is doing, it's because I selected multiple tables here, it's actually looking at all those tables, it's figuring out the foreign key relationships between those tables, how those tables are related. It's looking at all the columns, it's trying to automatically detect those semantic types for each of the columns to automate the process of configuring the data for your training process. But once it's done, we've made best guesses, and then you can go in and change those things as you need. So what I want to do for this is I want to show off those types. So I'm going to click this user table, and I'm going to click into the columns. And you can see we've got these semantic types, name, for example. So first name, last name, those are types names. Initials is a name. Email address is a specific semantic type. What we do there is with those semantic types, we group those into something we call an entity. So name and email get grouped into this person entity. And what that does is it models the relationship between those columns, even though there isn't really a correlation statistically across those columns. It treats them as a uniform block in the training process so that you get consistent data of names and emails out. So what I can do here is I've got a gender column here, and it automatically detected a categorical type, which is fine, but I could also change that to gender. And then what I have to do is I have to map. In this one, capital M is male, and we need to map it to lowercase. So I can provide this mapping. And then when I change it to gender, gender is one of these semantic types that's expecting to be part of a person entity. So there's already that person entity created, so I can add it to that. And now I've included gender as a part of that grouping for that entity. I'm going to get out of this for showing that, and I'm going to start with a new project, and I'm going to pull in some banking data, and we're going to show configuration of things like the model training and defining a sequence table as well to show how you configure the time series generation. So I give it a name. And I add more data. And here I'm selecting this banking data. This is 8 tables. So when I click that analysis, it's going to do the same thing. It's going to analyze all 8 tables, figure out the relationships, and then what we'll do is go in and configure one of those tables to be what we call a sequence table, and that triggers the availability of time series configuration for that particular table. We have 3 table types that you can define within DataMaker. The first is reference. So if you've got a table of data that you don't need to generate, you can use as is. Go back to the movie example. If you've got a table of movie titles, you don't necessarily need to generate movie titles. You can just use as that is. So you can set that as a reference, and that will just be used as is. Tabular will be generated using whatever algorithm you choose, currently SMOTE or PrivBase. And then sequence will open up that time series. So this analysis came back, and you can see it creates this model, visual model, and this transaction table is initially defined as tabular, and so what I want to do is change that to sequential. And what I'm going to do is the sequential ID, what we're trying to do is map transactions within an account across time. So the sequential ID is the account ID because we want transactions within an account, and then we want to sort it by the date. And what happens is, let's assume everything else is correct in configuration at this point. When I go to the training tab, at the bottom here, this new section shows up. That's the sequential setting. So this would not normally appear if you did not have a sequence table defined in your data. So when you've configured your data, the next thing to do is come in and configure your training options. And like I said, we support 2 options, SMOTE and PrivBase. We're going to do PrivBase today because that will show off the differential privacy options. SMOTE, by its nature, really can't have differential privacy because it's interpolative, but this new PrivBase model does support it. So when you select PrivBase, you can opt in or out of differential privacy. By default, we opt in, and then you select the amount of noise you want to put into that model as it's trained. You can opt for greater accuracy, so it'll be less noise. So greater accuracy, lower privacy. If you slide to the left, you get greater privacy, but you trade off accuracy. So really your use case is going to define where you set this value. And the nice thing is you can train, and then once we train, we'll show you evaluation. And you're in that typical train evaluate loop at that point. So once you've trained, you can say, oh, I need to try something different, and come back, tweak the settings, retrain, reevaluate, and then we keep a history of those trained models, so you can go back and forth between the different settings. So I'm going to leave the defaults here. We will be adding a lot of contextual help here to help identify what each of these parameters are. And if you want to dive into these, I encourage you to come to the booth. We can really dive into what these options are, what they mean. I'm not going to get into that level of detail for this demo. And then the final thing is the metric setting. So this is the set of metrics that you would like to produce, so that when we evaluate the model, we'll use these metrics to evaluate that trained model. I'm going to click Start Training. Now, this is going to take anywhere from 10 to 15 minutes to train with a sequenced model. I have one already trained, so I'm going to switch to that. It's the same data. I've got the transaction table that was set to sequential. I have my training settings that are the same as what I had before. And here's that ability to make a copy and edit. So if you decide you want to tweak this model, you can click that button, it unlocks the settings, you can tweak them, retrain, and get a history of your generations. When training is complete, this evaluation tab is populated. And along the top, you get a couple of aggregate scores that we calculate to kind of give you a really quick visual about how good the data is. And good is relative to your use case, right? So density disclosure is a privacy metric to know how good we did on the privacy side. And then we've got some similarity metrics that tell how statistically similar they are. And then presence disclosure is another privacy metric that we have. So you get these scorecards, but we also have charts at the bottom. And the charts you see are dependent on the type of variable you select. So this here is a categorical variable, so you see kind of bar charts of the different categories. The blue represents the distribution of that particular category in your source data. The pink represents the distribution in your synthetic data. And then you got the intersection. And the purple here is a little bit of a throwback to Hazy. Hazy's logo was purple. So we've kept a little bit of the Hazy culture by including some of this purple into the new data maker. So a little bit of an Easter egg for some of the Hazy folks. Here you can change which column you're looking at across all your tables and see these charts. Once you've decided that this is the right model for you, you can then click Generate. And this is where now you're going to use that trained model to generate new synthetic data. So I'm going to click Generate Synthetic Data. We're going to click the output destination here. Right now we support several file formats. We're working on adding the SAS formats in. A lot of this, we're using the base Hazy software, so we got to add some of the SAS things in. So that'll be in there for GA. And then you have this, how many rows do you want to generate? And that becomes a bit of a problem with multi-table because it's hard to know how many rows to generate for each table so that you get that true modeling of your source data. So one of the concepts that Hazy brought in that I really like is the concept of a magnitude. Now you can go in and specify your output rows, but the magnitude allows you to say, relative to the source data, how much data should I generate? So a magnitude of 1 means generate the same amount of data. Magnitude of 2 is generate double the data, so on and so forth. So you can do fractional as well, generate half the data, 0.5, right? So I'll generate 5 times the data, and what we do is we estimate, based on that, how many rows we need to generate in each of those tables, and we give you a calculation, an estimate of the total number of rows we're going to generate across all the tables. I can click generate, and that starts a process where it'll generate the data, put it in the output location that you've configured and selected, and then we'll get some information about how many rows we're actually generating, because we're giving an estimate. There's a little bit of fudge factor there with the statistical probabilities on generate to make sure we have what we need to show you. One thing that is different here is in the prior version of DataMaker, when we generated, we showed you assessments between the generated and the source. Here, we show you that after training, but not on generation, because the thought here is that anyone should be able to use this model to generate. And if the person generating doesn't have access to the source data, you don't want to show them any similarity statistics, because that could inform them of the actual source data. So this process will take a few minutes. I'm going to switch back to the presentation real quick, and then we'll come back here to make sure we're staying on time. So after GA, which we're targeting in Q3 this year, what comes next? Like I said, we've got a ton of additional models that Hazy brought. We've got a lot of SaaS models we would like to pull in here, but we want to incorporate the differential privacy work into the SaaS model. So that's work that you'll see in DataMaker, but will also be a benefit to general SaaS customers as we incorporate that differential privacy work into our base SaaS models. Data connectors, I kind of glossed over this a little bit, but right now it's configured for Azure Blob Storage. So it's files in Azure Blob Storage, and you configure input locations, output locations. Hazy has a whole suite of data connectors, so Snowflake, Oracle, S3 buckets. So kind of as we move through incorporating those in, you'll see those pop in, and because of the nature of the application, as we implement those features just kind of get into your environment as they do. Expansion of the cloud support, we're targeting Azure to start, but we know we have customers on AWS and GCP, so those things are on the roadmap. I can't speak to timelines. And obviously via integrations, we want to be able to make sure that you can use this data, the DataMaker application, where it makes sense, touch points within the applications itself, making it easy to get the data into VIA. But it's important to note that because it's standalone and not tied to VIA, if you're a SAS 9 customer, you can take your synthetically generated data here and bring that into your SAS 9 environments as well. So by being standalone, it offers a lot of benefits to our customers across the SAS products. And with that, I think we have a couple of minutes for questions.
How do you tackle changes in the source data set? So addition of columns, do you have to go back retrain? What's the process?
You would have to go back and reanalyze. So when we analyze the data, we take a snapshot of what the data looked like at that point, and that's where we keep track of all the columns and their types. So if your data shape changes, new columns, new tables, relationships, you would have to reanalyze. Training may actually break if you don't reanalyze and you try to train and the tables look different than what we think the data configuration looks like. The training's probably going to fail. We probably should detect those types of situations, and those are features that will come in as we see how customers are using this
Wonderful. Well, thank you so much, Sean. If you have any questions after, please feel free to come up. Please return your headphones to the back table. And thank you so much, Sean.
Thank you.